Okay, number 10. Oops, not there. It's over here. Okay, so number 10, this one looks like it's geometric to me, and that's one of the things you do need to know for the AP test. So what I'm going to do here is I'm going to rewrite this series as, so this series is going to equal the summation from 1 to infinity. Instead of 2 to the n plus 1, I'm going to write this as 2 to the n times 2. If you want to put the 1 there, you can. Over 3 to the n. And because 2 is like a coefficient, I can pull out the 2 in front of the fraction. So that means I can pull out the 2, this 2 right here, I can pull it out in front of the sigma. So this is going to be 2 times the summation from 1 to infinity. And then this part right here, I'm going to write this as 2/3 in parentheses raised to the n. Okay, so now this is going to equal 2 times. If I want to figure out what this equals, I'm going to use my formula. I'll write it off to the side. So the sum of an infinite geometric series is your starting term over 1 minus r. So to figure out what the sum of that is, I'm going to do the starting term, which there's an invisible 1 right here. So we're starting with, is that right? Let's see. Starting with 1. Actually, normally that would be the case. That's when you're starting at n equals 0. Because we're starting at n equals 1, when I plug 1 in for n, it's going to give me a starting term of 2/3. So again, this 1 right here that I wrote, that would be your a, assuming n equals 0. But because n does not equal 0 here, you have to plug in 1 for n. So 2/3 to the 1 is 2/3. That's your starting term. On the bottom, it's 1 minus r. R is always the base. So your base here is 2/3. So I just have to figure out what this equals, and that'll be my answer. So this is going to equal 2 times so this is going to be 2/3 divided by 1/3, which you could times the top and the bottom by 3, so those just go away. So it's just going to be 2. So 2 times 2 is going to give you your answer, which is 4. Yeah, make sure to reference which topics you're expected to know. Not that the other ones aren't important, but it just makes sense to spend the time you have on what you expect to see on the AP test. So is that okay for number 10?
So why is the 2/3 on the top part?
The 2/3, because when I plug in this, see this 1 here that I'm circling? When I plug that in for n, that's going to give me my starting term. So 2/3 to the 1 is just 2/3.
Oh, okay.
If it was n equals 0 down here, that would just create 1. So that's when you would use this number right here as your a. But because there's not a 0 on the bottom of the sigma, you can't just use that shortcut.
Okay.
So when in doubt, if you want to find the starting term, just plug the number in at the bottom and for n, and that'll give you the starting term. Okay, so other questions on this page?
Do 11.
Yes, let's do 11. Did I told you to do 11, or did I say to skip that one?
You can skip it.
I think that one's a power series. I don't think they're going to have power series on there. You will have to find a Taylor polynomial, but I don't, one of the concepts was on power series, and that one you wouldn't have to know that one. But so yeah, I'm probably gonna, I'll skip number 11, so we can just focus on the time on the
Okay.
proms that you're expected to know.
Can you do 14?
14, yes, let's look at 14. There is a chance I may have messed up a couple, but I think I just looking over them pretty closely, so hopefully I told you the correct ones to skip. So let's look at 14 now. Oh, I think 14 is on the next page. I'll do that first when we go to the next page. So anything else on 1 through 13? This is the time to ask. What's that?
12.
Let's look at number 12.
Yeah, 12.
Okay, so number 12. I'm going to do 12 down here where there's more room. So this is problem number 12. So it goes with this one up here. Okay, so number 12, it says the rate of change of the volume of water with respect to time. So that's another way of saying dV over dt. And it says time t. And then it says the word is. So is means equals. It's directly proportional. When it's proportional to something, that means it's something times k. So it's directly proportional to the square root of the volume. So it's the square root of the volume multiplied by k. Which of the following is the differential equation that describes this relationship? So that would be letter C. So it's just like translating English into math symbols, into calculus symbols. So is that okay for number 12?
Yeah,
So
thank you.
Directly proportional is just some number times k. Okay, what else on this page?
Isn't the answer E?
I hope not. Oh, you're right. I looked at it wrong. Okay, thank you. I have the answer right down here, but I don't know why I thought C was the same thing I had. So E is correct. Thank you. Okay, other questions here. Anything else on 1 through 13? We're good. And these are the ones I want to make sure that you are good on. So last call, anything on 1 through 13?
7.
Number 7. Let's look at number 7. Oh, I think, did I tell you to skip 7? Anyone?
Yeah.
Okay, so I think anything that says parametric or has to do with like X, Y, and T, if it has to do with all three, if it's parametric, let me see, position of the particle. Yeah, you could skip 7. They might ask you along one axis. You might have to find a rate of change, but it's not going to look like number 7.
Can you do 14?
Yeah, so I'm gonna do 14 on the next page, first one, but anything else on 1 through 13?
Just a general question. Where do we find the answers
Yeah.
to questions?
If you go to the end, I'll go there now. Let's see. So if you go to the very last page, you can see all the answers, and you
Oh,
you see like number 1 must be one because 96% got it right. So I would actually say focus most of your time on the ones that a lot of students are getting right, because those are the ones you need to get correct. So you see one like number 7, only 29% got correct. There's some that are really low. So there's quite a few problems that less than half of students get right. So just something to keep in mind, but I think it's a better use of your time and energy to really make sure you know how to get like the easy and medium level problems right. Some of the ones that are like 25% correct, it probably takes a lot of your time trying to figure it out, and it's probably one you may end up even just skipping on the AP test, even though I'm not sure that this year it's a little bit different. So they are making some new announcements on April 3rd, and I'll try to keep you posted, but I'm hoping they give a little bit more detail on I know it's going to be free response, but so it's a 45-minute test for free response, but other than that, I really don't know much other than the topics that they said that are not going to be covered. Okay, so last call. Anything else on 1 through 13? So we're good here? All right, so I'll do 14 now. So 14 is a slope field. Okay, so for this slope field, I like to figure out like where the derivative is 0 first. That's just, there's different ways you could do this, but where the derivative is 0, that's where the tangent line is horizontal. So like right here it has a slope of 0. So all the way down the y-axis, it has a slope of 0. So what I'd make a note to myself, I would say the derivative equals 0. Whoops. When anything on the y-axis, doesn't that have an x-coordinate of 0? So whenever x is 0, it's going to make my derivative 0. So that might be a good starting place. So actually, I don't know if that helps me here, because on this one, every numerator in all 5 answer choices, every numerator has an x in it. So x would be 0. So normally I think that would be helpful, but for this one, not so much, because all 5 answer choices have x in the numerator, which would make the slope 0. So let's figure out quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so I'm actually going to clear this out. But normally what I just did would be helpful, but just not for this one. Okay, so for this one, for quadrant 1, if you notice, everything in quadrant 1, isn't it going up from left to right? So dy over dx is positive everywhere in quadrant 1. Quadrant 2, actually this is quadrant 4 down here, so maybe I'll just do quadrant 4. Also everything is positive. because in quadrant 1 and quadrant 4, all of the hash marks are increasing from left to right. So quadrant 2 and quadrant 3, it looks like everything is decreasing. So here I would say no matter where you are in quadrant 2, the slope is always negative. Same thing in quadrant 4 or quadrant 3. Anywhere you are in quadrant 3, it has a negative slope. So let's see if that helps us. So coming down to the choices. In quadrant 1, the x and the y coordinate are both positive. In quadrant 2, you go left and up. So it's always going to be negative, positive there. Everything in quadrant 3, you go left and down from the origin. So it's negative, negative. Everything in quadrant 4, you go right and down from the origin. So it's positive, negative. So let's go through these. On letter A, it says the derivative is x over y. Let's see if that works. So if you do a positive, I'm in quadrant 1 now. If I do a positive divided by a positive, that gives me a positive slope. If I go to quadrant 2, when I divide x and y, it'll give me a negative slope. Quadrant 3 is false. So I'm going to cross this one out. So the reason quadrant 3 doesn't work, the x and the y coordinates are both negative. So what's the negative divided by a negative? Someone speak up.
Positive.
Positive. But doesn't quadrant 3 have a negative slope? So it's not going to be, it has to work for all 4 quadrants. So it's not going to be A. So let's go to B. X squared over y squared, that can never be negative. So that wouldn't be consistent with quadrants 2 and 3. So I can rule this one out, because x squared over y squared will never give you a negative slope. For letter C, let's go quadrant by quadrant here. If you're in quadrant 1, you would have a positive over a positive, which gives you a positive slope. In quadrant 2, you'd have a negative over a positive, which gives you a negative slope. In quadrant 3, you have a negative over a negative, which gives you a positive slope. So this one won't work. So again, if x and y were both negative, like in quadrant 3, you would get a positive slope. But if, according to the graph, quadrant 3 always has a negative slope. So let's go to 4. X squared over y. So x squared, if you do quadrant 1, it's going to give you a positive over a positive, which is a positive slope. That's what we have on quadrant 1. Quadrant 2, it's going to give you positive over, the y coordinate is positive. So it doesn't work, D does not work in quadrant 2, because you have a negative x coordinate. When you square that, it becomes positive over a positive y value. A positive over a positive is going to be a positive. But according to quadrant 2, the slope is negative. So that contradicts what we have. So the answer must be E, but let's talk about why. So let's go through all 4 quadrants. So for quadrant 1, everything's positive, so that'll work. So quadrant 2, the x coordinate is negative. When you cube a negative, it makes it negative. A negative divided by something squared is positive. So a negative over a positive gives you a negative slope. So that's what we have here. So quadrant 1, we ended up always with a positive slope. Quadrant 2 is negative. For quadrant 3, x coordinate and y coordinates are both negative. So that's going to give you a negative over a positive. When you cube a negative, it's negative. When you square a negative, it's positive. So that's going to be negative, so that works. And then for quadrant 4, the x coordinate, you have a positive. The y coordinate doesn't is being squared, so it's always positive. And a positive over a positive gives you a positive slope. So E is the only one that's consistent for all 4 quadrants.
How long is that supposed to take you? Oh, wait, never mind.
Well, it's a good question. I mean, if you feel like you're taking, I mean, this might not apply with the AP test you're taking, but if it feels like it's taking you too long, I mean, just go to the next one, and if you have time, come back to it. There's no rule that says you have to go in order.
Mr. Morrison, can you do 15?
15, yes. Let's look at 15. Didn't you guys miss calculus last week? Maybe you're doing calculus, I don't know. But all right, so 15, you do need to know arc length formula for a function. But if it's parametric, you don't have to worry about that, or even polar. So I've given you 3 arc length formulas. You're only expected to know one of them, which is this one here for a function. Okay, so on 15, I'll do 15 up here. We have more room. So on 15, so the formula I'm going to be using is it's the integral from a to b of the square root of 1 plus f prime of x squared dx. So this one, they're giving you the integral. So this right here has to equal this up here. So I'm going to write a new equation. It says 9, keep doing that. So 9x to the 4th equals my first derivative squared. So I'm going to take the square root of both sides. When you take the square root of 9, you get 3. When you take the square root of x to the 4th, you get x squared. And I take the square root of the right side. It's f prime of x. So my derivative is going to be 3x squared. So if I want to find, it's asking me about which is the original function. So the original equation would just be f of x. So if I want to find f of x, I have to take the integral of both sides. So I already took the integral of the right side, it's just f of x. I take the integral of 3x squared, you add 1 to the exponent, so you get 3x cubed over 3, which is just x cubed, don't forget your plus c. And it gives an initial condition here. So it's giving you the 0.16. So that means when f of x is 6, x is 1. So when I solve this equation for c, 6 minus 1 cubed, 6 minus 1 is going to be 5. So I can take 5, plug it back in here. So that's going to leave me with my answer. F of x equals x cubed plus 5. Here they're just using a y instead of f of x. So it's going to be letter B.
Mr. Marson,
Yep.
that equation in the beginning, that's arc length, right?
Yeah, so this formula up here, this is the formula to find the arc length of just the normal function.
Is that
No polar coordinates involved, no parametrics involved, just a regular function.
are we
So that's the one you should know.
Are we gonna have any of those?
That could be on there, yeah.
Okay.
Because everything we've done first semester can be on there, and we did this. That was something we did towards the end of first semester. It was in your 7.4 notes. But the stuff that's not going to be on there, which I was a little bummed about at first, but I kind of got over it quickly, especially because a lot of the stuff they took off are the harder topics, like Lagrange error, some like graphing, finding the area of polar curves. Those are all eliminated from, they said, maybe because a lot of teachers across the country around the world haven't covered that yet. My plan was to just go through it quickly so we'd have lots of time to review, but that's okay. It was still, even in doing those, we were still covering a lot of the old stuff, so I don't feel bad anymore.
Cool. Thanks.
Okay, so other questions on
We
this
do
page?
17.
18.
17. I'll do 17 and 18.
15.
I just did 15, silly.
Sorry.
Okay. It's okay. All right, so 17 and 18. Try to remember that. Remind me if I forget. So I'm going to do 17 now. Wait, 17 we don't have to do. Isn't that
You
parametric?
don't need to do it.
Did I tell you to skip
Yep.
17?
Meant to say 16,
Okay.
by the way. Sorry.
It is possible that I missed it, but okay, so I'll do 16 and
I
18.
misread.
But yeah, anything that says the word parametric should not show up on your AP test. Okay, so 16. I'll do 16 up here also. So number 16, it says the word tangent. So whenever you see the word tangent, doesn't that mean you have to find the slope? So to find the slope, well, in this case, it's giving you 2 points. So this doesn't even involve calculus. It's just, well, it kind of does, because you have to recognize that the tangent line is the same as the derivative. So to find the slope of a tangent line, you just do y2 minus y1 over x2 minus x1, if you know 2 points on the tangent line. And that's the same as the derivative. So that's the only calculus there. It's just recognizing that the derivative is the same as the slope of the tangent line. So I'm going to do y2 minus y1, so negative 2 minus 7 over, so I'll say this is x1, y1, and this is x2, y2. Then on the bottom, I have negative 2 minus 1. So this is going to be negative 9 over negative 3, which equals 3. And this m is the same as f prime of 1, because here it tells you that it's a tangent line, and when x equals 1, it's going to be 3. Okay, so then 18, I'm going to clear this out. There are no questions on 16. Then I'm going to switch over to number 18. Okay, so number 18. So 18, I don't think I've ever seen an AP test, well, I know I haven't, where it doesn't have fundamental theorem of calculus on it. So I'm guessing just even 45 minutes, I'm still be surprised if you don't see anything that has to do with fundamental calculus on there. Okay, so on 18, it gives us this here. Let me highlight this. It gives you this, but then it asks about the derivative. So what I need to do is I'm going to take what I highlighted in yellow and take the derivative of both sides. So g prime of x I just took the derivative of the left side. Now I'm going to take the derivative of the right side. That's fundamental theorem of calculus. So when you do that, you're taking the derivative of the integral, so they undo each other. when you have a constant on the bottom, it has no effect on your answer because we did it the long way back in your, I think it's 5.4 notes. You end up taking the derivative of a constant later and it just goes away. So all you have to do is take 2x and plug it in for t. But 2x is a function. So this was extended fundamental theorem of calculus. So then you also have to times by the derivative of 2x. So someone with their microphone on, tell me what's the derivative of 2x?
2.
Times 2. Let's make sure we're staying with me. Thank you. Yeah, I know I can't see all of you at once. Sometimes I scroll down, but yeah, just make sure you're staying with us. You know, some of you don't have, most of you have a camera. So right now, Jason Kramer, can you turn your camera on? Aisha. And Connor, can you turn your camera on? As long as you're decent, everyone. Most of you have your camera on, so that's good. Okay. I just want to know you're here and not just wandering off. Okay, so from here, what's the next part? It says find g prime of 3.
Yes.
Okay, so that's going to be f of 2 times 3 times 2. So g prime of 3 is going to equal f of 6. Whoa, that's an ugly 6. So f of 6 times 2. Then we need to find f of 6. We need the graph. Okay, so I'm going to go look at the graph here to find f of 6. So f of 6 is just the y-coordinate when x is 6. Notice it says at the bottom, graph of f. So we're given the graph. So when I find f of 6 here, so when x is 6, what's the y-coordinate at this point?
-2.
Negative, is it -2?
-1. -1, sorry.
Negative
-1,
one,
thinking of
right?
the answer.
Oh, okay, so you're one step ahead of me. So -1 times 2. So the answer will be -2. So this is equals. So that's letter C.
Well, I don't exactly get the times 2 part. Is that because, did you take the derivative of 2x?
Yes. So whenever you have a function as one of your limits of integration, so if you go back to your fundamental theorem of calculus notes, there was fundamental theorem of calculus and there's extended fundamental theorem of calculus. So the extended part is when your limit of integration is a function like 2x or x squared. You just plug whatever that is into your dummy variable, which in this case is t, and you times by the derivative of that function. So the derivative of 2x would be 2.
Okay, thank you.
Uh-huh. Okay, other questions on this page?
20.
20? Let's look at 20.
20 was a skip.
You don't have to do it.
Okay. This makes it easier being able to skip problems. This whole thing is growing on me more each day.
Could you do 21?
Look at 21.
19.
So I'll do 21, then 19. Remind me if I forget. Okay, so on 21, see the best way to do this. Okay, so on 21, okay, so I'm glad I want to be able to do more logistic problems. So there's actually, with everything going on in the world right now, there's a lot of calculus. One of them is logistic growth. That's to do with the spread of a disease. It's kind of starts growing exponentially, and you hear that phrase flatten the curve. They want it to start kind of leveling off before it gets too crazy. So, I mean, you see also see graphs like this. This would describe the total number of people that are infected. The top graph, logistic, would describe all the total number of people that ever get infected by the virus. So, because some people, this reflects that some people are recovering. So eventually it should start going down, the total number of people that are currently infected. Just another kind of side note, a cool thing that I just saw a couple days ago. They were talking about how the virus is mutating. They're saying that they can already tell, they looked at the rate of change and how it's mutating, and they can tell that once they're able to come up with a vaccine, that the vaccine should last like at least 10 years. So it's not like the flu shot where you'll have to get it every year, but they're using calculus to determine that. They're looking at like between a few different periods of time, they're able to see how the virus is changing. And if it's not changing very much, you won't have to get like a vaccine every single year, which is nice because the flu is constantly changing. That's why they recommend a flu shot every year. So just fun facts. It has to do with the current world we're living in right now. So 21, let me erase this. Okay, so this is a logistic differential equation. Remember, a differential equation always describes how something is changing. So when you're graphing a differential equation, you're not graphing the original function, you're graphing how it's changing over time. So in this case, we have a national park modeled by the function m that satisfies the given logistic differential equation, where t is time, and it gives you an initial condition. So initially, there are 0. The plural for moose is moose, right? And does anyone know the plural for moose? I feel like I've asked people that before, and I get different
moose.
responses.
I-
Isn't it just
Geese.
moose?
It's moose,
It's
right?
moose.
The moose. I know goose is geese. I know
Yeah,
mouse
it's not
is mice.
meese. It's definitely not meese.
I don't think it's moose. Okay, so I'm just going to say moose for plural.
I think
Okay,
it should be
so
meese.
it should be me. So goose is geese, you would think, but I don't know. Yeah, I've never been able to hear people agree on this one. So I've even heard mooses. I don't think it's mooses, but anyways, let's focus on calculus. So the moose, we have 21 dm over dt. Okay, so the formula I'm going to use here is dm over dt is going to equal, it's proportional to something, that's why it's k times m times, and I have 1 minus m over, I'll say, what did I call the carrying capacity earlier in the year? Did I say C? I think I used M. I'll use C for the carrying capacity. So where C is the carrying capacity, that means the maximum number of moose the park can hold before it doesn't have the resources to for them to continue growing in population. C is max carrying capacity. So again, this equation tells you how the population of moose is changing over time. Okay, so I'm going to write this as, what is it asking? What is the limit? Okay, so here, if you write it this way, C, if it's in this form, is just going to be factor out a C if you wanted to. But this is one way you can write a logistic growth differential equation. So if you can identify that this form here is the same as the form that's given to you, that gives you the limit as t goes to infinity. So as the number of years approaches infinity, the maximum number of moose you can have would be 200 based on the given equation.
Mr. Marston, how many ways
Yes.
are there to write that equation?
Probably infinitely many.
Well, the one.
But usually there's gonna be like a couple ways. Like you could also write it like this.
That one's the most common though, right?
I'll give you the two most common. So if I factor out a C, let's see, this would be 1 over C minus M. That's not right. Hold on. I wanted to factor out an M. So if you factor out an M, it makes it an M squared. I got confused because usually the maximum carrying capacity is M. But here I'm using M for the population of moose. Okay, so if I factor out an M, it would look like this. And then this would be 1 over M minus divide 1 second. This M thing is messing me up right now. So when I factor out an M, or you know what, let me start over again. I'm gonna factor out.
Take your time.
I want to make the 1 in M. So when I make the 1 in M, it would look like this minus, let me divide this by M. We get 1 over C. The variables are really messing with me right now. Normally this is not normal.
Wouldn't it be M squared over C?
It would be M squared over C, yeah.
It's okay. I can honestly just roll with that first one. It's not that big a deal.
It's important to know how to put them in different forms. It's okay, M squared over C. So I'm sure we'll see some more as we go through these. But that's, yeah, this one focused on the one I have in blue.
All right, thank you.
How do you know that it increases to the carrying capacity? Like, how do you know whether or not the population will increase or decrease?
Anytime it's logistic differential equation. Here, another way you can write it. I mean, before I do that, I'm just going to use it so the variable doesn't mess me up. You can say it's proportional to the population and the carrying capacity minus the population. So it's always going to increase because the population is always positive. And if you take the maximum carrying capacity, that's always the most it can be. And you subtract the current population, that's always going to be positive because P can never be bigger than C if C is the maximum carrying capacity. So a positive times a positive is going to make your rate of change positive.
But what if K is negative then?
K wouldn't be negative for logistic, because it's called the logistic growth function. So
okay.
it's going like this, and the graph is gonna it's gonna have a point where the rate of change is the greatest. So this point right here is gonna be where it's changing it's the fastest rate of change. where it changes concavity at the inflection point. But yeah, it's always going to be increasing, and it's going to correspond to this graph for logistic growth.
Okay, thank you.
Mm-hmm. Okay, other questions?
$19.
19. Let's look at 19. Oh, that's right. I think you asked that earlier. Oh, okay. Okay, so number 19, I'm going to do this one up here. So on 19, it says this curve has a slope of 2x plus 3. So a slope is the same, m is the same as saying f prime of x. It actually equals 2x plus 3. Don't find the slope of 2x plus 3 because this means the slope is changing over time. So it's not going to be linear. So the slope, the curve has a slope of 2x plus 3 at each point. Which of the following is an equation for this curve if it passes through the point 1, 2? Okay, so I am going to find the integral of both sides. I'm trying to get back to the original equation. So we saw a problem like this one earlier. So to get back to the original function, I'm going to take the integral of both sides. So on the left side, the antiderivative of the derivative is just f of x. Gets you back to where you started. When you integrate 2x plus 3 dx, it's going to be x squared plus 3x. Don't forget, when you're taking the integral of an expression, an indefinite integral, you always do plus c at the end. And that's where the initial condition comes in. So you're given the point 1, 2. So I'm going to plug in 2 for the y coordinate. And then I'm going to plug in 1 everywhere I see an x. I don't know what this is here. All right, so now this is going, oh, that was a parenthesis. I couldn't figure out what I wrote. So this was a parenthesis, 1 squared. So 1 squared is 1, plus 3 is 4. Subtract 4 to both sides, you get negative 2. So I'm going to take negative 2, plug it in for my c, and it looks like all the answers, choices have y instead of f of x. So I'm just going to put a y here. And it's going to be x squared plus 3x, and then I'm substituting for c and negative 2. So it looks like letter D.
Out of
Is that okay?
curiosity, why
Yeah.
wouldn't you put 2x plus 3 equals 2 minus y over 1 minus x and then try to solve?
Because you only have 1 point. So you couldn't,
Oh, okay.
yeah, if you had 2 points and you knew the slope, then you could find y2 minus y1 over x2 minus x1 and set it equal to that. But here they only give you 1 point.
Okay, thank you.
Uh-huh. Okay. Anything else on this page?
Can you do 23, Morrison?
23, I can. So let's look at 23. I miss doing integral problems. It's been a while. Let's see. So I'll put 23 right here. So I'm looking at that one and I'm thinking integration by parts because I have two factors. One of them's algebraic and one of them's trig. So hopefully everyone can tell by this point that we're going, or like what to do first when you're integrating. So U substitution is not going to help me here because I can't take the derivative of either factor to get the other factor. And then I don't have a rule that lets me undo a product, take the antiderivative. So I'm going to do integration by parts. So integration by parts, I need to know U and dV. You could even do tabular integration here if you wanted. Well, I'll just do dV. So think Liade. So do we have a log anywhere in this problem? Any natural logs? No. Do we have inverse trig? No. Do we have algebra? What's our algebraic factor?
X.
X. So that means everything else is your dV once you identify whatever U is. So whatever's left over is your dV. So that's sine of 6x dx. Okay, so I'm going to find du. That's just dx. And then v, I'm going to take the integral here. So there is a rule. If you have sine of, you're taking the integral of sine of kx, it's just sine of kx over k. Or it's the integral of sine, which is, it'll be cosine, negative cosine of kx over k. You could also do this one by U substitution if you forget the rule. But I'm just gonna, it's gonna be negative cosine kx over k. So my k is 6. So now I'm gonna use ultraviolet voodoo. So it's uv minus the integral of v du. So u times v is gonna be negative, oops. It's gonna be negative x cosine 6x over 6 minus the integral of v du. So that's going to be negative cosine 6x over 6 times du, which is just dx. So this is going to equal negative x cosine of 6x over 6 minus the negative becomes a plus. I can pull out the 1/6. All right, and now I'm almost done. So for my final answer, I can say this equals negative x cosine of 6x plus, well, the integral of cosine of 6x is just sine of 6x over 6. So that means it's gonna, if it's over 6, I can pull out a 1/6. 1/6 times 1/6 is 1 over 36. Sine of 6x. And I need the plus c at the end. So 23, that looks like letter B. It's the same thing.
Do you mind showing tabular integration, or at least like explaining how to do it?
Yeah, I can do tabular. So any questions before I clear this off and do it using tabular, which would probably be, yeah.
Can you explain
Was there a question?
Yeah, could you explain one more time where you got the 36 from?
The 36, yeah. So if I was to do the integral of cosine of 6x, there's a rule for this. It's just going to be sine of 6x. It's sine of kx over k. So here your k would be 6. But if you don't remember the rule, you could do this one using u substitution. And then I can write this as 1/6 times sine of 6x. And when I times this by the 1/6 in the front, for 36.
Thanks.
Should be a dx here. Is Chris not here? I haven't heard Chris chime in. You hear Chris?
I've been feeling nice, I didn't feel like,
Okay. I'm just so used to someone calling out when there's not a dx there.
Nah, I've been a little quiet. I'm insecure with so many people here. I feel like
Oh, that makes sense.
Yeah.
I know it can be a little overwhelming.
Fourth period people, so I don't like it.
Okay. All right. Okay, so I'm gonna do tabular now, same problem. So an easier way you could have done this, tabular only works when one factor integrates repeatedly and the other differentiates down to 0. So here I'm gonna do x and then sine of 6x. So x is the one that differentiates down to 0. So you take the derivative of x, it's going to be 1. You take the derivative of 1, it's going to be 0. Sine of 6x, I can integrate that repeatedly. So this is negative cosine of 6x over 6. Another way to write that is negative 1/6 cosine of 6x. And then when I take the integral of this, it's going to give me negative 1 over 36 sine of 6x. And then it always alternates signs because you're doing minus voodoo each time. So that takes the opposite of the next term. So it goes positive, negative, positive. And you just draw arrows down like this. So this can take you straight to your answer. So the final answer, if you multiply where the arrows go, it's going to be negative 1/6 x cosine of 6x. Negative times a negative makes this a plus. 1 over 36 sine of 6x. Don't forget your plus c at the end.
Thank you.
When will that not work?
What was that again?
When would that not work?
It wouldn't work if like this x didn't differentiate down to 0. So it works usually when it's either algebra times trig, or if it was like algebra times e to the x, which would be exponential. Because trig and exponentials are the ones that you can keep taking the integral of over and over again, and it's not that hard. But it has to have an algebraic factor because that's what's going to differentiate down to 0. You keep taking the derivative. So it has to meet two rules. One factor has to differentiate down to 0, like x does, and the other factor you have to be able to keep taking the integral. Okay, other questions on this page? All right, I'll clear this out. Go to the next page. Moving right along. Okay, so this is 24 through 80, skipping a few numbers in the middle.
Can you do 24?
24, yes. Let's look at 24. So remember, there will be some series. It won't be as extensive as what we covered in class, but you will have to know series for the AP test. Okay, so which of the following series diverge? So if you look at this first one, that's geometric. So sine 2 over pi. Doesn't sine always have to be between -1 and 1? Everyone's okay with that? So the biggest that sine 2 could equal would be 1, even though it's going to be smaller than 1. So if you have, let's pretend it's the biggest you can make it, 1 over pi. Isn't that still, won't sine of 2 always, sine of anything will always be less than pi? That's called a proper fraction, when the numerator is smaller than the denominator. Whenever the numerator is smaller than the denominator, isn't that fraction value less than 1? So right here, because this number right here is smaller than 1, this is a geometric series. If it's smaller than 1, this converges. So this would be false. It does not diverge. All right, rather than saying false, I'll just say C for converges. Or I'll abbreviate it, C-O-N. So this one converges, C-O-N-V. The next one is a P series. So it's going to be 1 over n. There's an invisible 1 right here. So it's n to the 1 over 3. Because 1 over 3 is between 0 and 1, this P series diverges. So 2 diverges. And for the next one, even though you don't have to know nth term tests, you can do nth term. Maybe it'll help you. I don't know. There's this possible something that we learned this isn't required could actually help you. So I don't want to rule that possibility out. But in this case, as n goes to infinity, this plus 1 is insignificant. So e to the n over e to the n is 1. So if the limit as n goes to the infinity equals 1, and 1, of course, does not equal 0, this also diverges by nth term test. You could also do L'Hopital's rule here. If you have infinity over infinity. Actually, that wouldn't help you, never mind, because you keep getting the same thing. So you would just simplify this limit to equal 1. And if it doesn't equal 0, it diverges. So for 24, the 2 series that diverge would be number 2 and 3. So that would be letter D. Other questions?
27.
27. So 27 is another fundamental theorem of calculus problem. I told you that was the most important lesson of the year. And the reason is because it always shows up. I'm guessing it'll show up somehow again this year. One way or another, they'll probably get it in there. So 27. Yeah. There's a little bit more room here. That's nice. Okay, so for 27, the constant 0 at the bottom on 27 is not going to matter. Again, we did it without using any shortcuts back in the notes. I showed why when we do it the long way. Eventually, it causes you to take the derivative of a constant, which is just 0. So we're going to use the shortcut formula. The shortcut formula says I can take x cubed and I can plug it in for t. So when I plug it in for t, I have ln. So this is when you use fundamental theorem calculus when you're taking the derivative of an integral. So that's what we're doing here. We're taking the derivative of an integral. So it's going to be ln, instead of t, I would write x cubed. So when you square x cubed, you multiply the exponent, so it's x to the 6 plus 1. But then you have to remember one very important step, because if you stop there, you would say the answer is c, but c is not the answer, because isn't x cubed a function? So you have to multiply by the derivative of x cubed. What's the derivative of x cubed?
3x squared.
3x squared is correct. So that is the same as letter E, just with the 3x squared in the front.
Can you do 26?
26.
I have a question on that one.
Yeah.
Like after you plugged in the variable, you don't still have to take the derivative of it.
No, when you're doing fundamental theorem of calculus, you go straight to your answer, because it's the fundamental theorem of calculus. You're plugging in for your dummy variable and then timesing by the derivative of your limit of integration, and that's your answer. So this is allowing you, because the derivative of an integral, they undo each other. If this is confusing you why, we did a couple problems a long way. I think it was in your 5.4 notes. You can look over that if you want to understand why it works.
So you don't have to worry about the d over dx, really?
Well, you're taking the d over dx of the integral, so it's like they cancel each other out. The derivative of the derivative. Okay, so I'm going to clear this and do 26. 26 would be easier in class, where I could like put my finger over things to do partial fractions. But it is what it is. So let's look at 26. All right, so on 26, I'm going to write this as 2x over x plus 2, x plus 1. This is going to equal some constant over x plus 2 plus some constant over x plus 1. So if you want to solve for a, I'm going to be focusing on this here to solve for a. So if you want to solve for a, what number would make the denominator 0 under a?
-2.
-2. So what I would do here is I ignore this part and then plug in -2 for x. So you have -4 on top, -1 on the bottom. So -4 divided by -1 is going to be 4. If you want to solve for b, what number would make the denominator under b 0?
-1.
-1. So what I'm going to do here is I'm going to ignore this part. And then I'm going to plug in -1. So 2 times -1 is -2. On the bottom, -1 plus 2 is 1. So -2 divided by 1 is -2. So that means I can take my original integral right here, and I can rewrite this integral. I can plug in this for my a and this for my b. So it's going to be the integral of 4 over x plus 2 I'm going to change this to a minus because it's a negative 2. Then I have 2 over x plus 1 dx. So this is going to equal, you can pull out the 4 in front. Think of this as two separate integrals. So for the first integral, I'm going to pull out the 4. And then I'm left with 1 over x plus 2. So the integral of 1 over x plus 2 is natural log of the absolute value of x plus 2. Then for the next one, I'm going to pull out a negative 2. And then I'm left with 1 over x plus 1. So when I take the integral of 1 over x plus 1, it's going to be ln of the absolute value of x plus 1 plus c. And my answer is D.
Thank you.
Can you do 77?
What's that?
77.
Which one?
77.
77, yeah. So any questions on 20? Okay, so I'll do what's that?
28.
Okay, I'm gonna do 70. I'm gonna do 77. I'm just gonna take one question at a time. I'll do 77. Any questions on 26 before I do 77? Okay, so 77 is a calculator question. The good news is April 3rd is only 4 days away, so I'm hoping by the end of this week I'll be able to give you more helpful information. But right now, no matter what we find out, I definitely see value in doing a lot of multiple choice problems. So 77 is a calculator question here, even though it doesn't necessarily mean the calculator is required. So I don't know how much of the test, if all or none of it, you can use a calculator, but I'm guessing I'll find that out by the end of this week. So on 77, it's not adjusting. Here, let me test something. Okay, I think I'm gonna unshare, then share it again. Having a little technical difficulties here. 77. Okay, so on 77, you can rate this as, this is the same as the integral from -3 to 3 of f of x dx plus the integral from -3 to 3 of 1 dx. So I'm going to start by focusing on this one here. So if you want to find this integral from -3 to 3, it says the area of each region is 2. So that means, let me highlight it here. So this area is going to be -2. This will be +2. This will be -2. So I'm going to say this is -2 right here because it's under the x-axis. For this integral, it's going to be +2. And then is going to be 2. So when you add up -2 plus 2 minus 2, that's just going to give you -2. Okay, so now I'm going to focus on this integral, and then I'm going to add that to -2. So I just found the area from -3 to 3. of the graph f of x is going to be -2. So to find this one, here I am going to take the integral of 1, which is just x, from -3 to 3. So this is going to equal -2 plus this is going to be 3 minus, then I plug in the -3. Change this to a bracket. So this equals -2. 3 minus -3 is 6. So -2 plus 6 is 4. That was a fun problem. So the key step here is being able to split up the integral, because you don't want the +1 to mess you up at the beginning. So make sure you write that as a separate integral. Okay, other questions?
28.
28. So I'll do 28 now. Okay, so 28. What is the coefficient of x squared? Okay, so right here, I need a little more space on this one. So you do have to be able to write Taylor polynomials, even though this is a Taylor series. This is based off of Taylor polynomials. So I thought this one would be good practice. So I'm going to say that f of x equals, I'm going to write this problem as 1 plus x raised to the -2. So when I take the first derivative, I'm going to go to the second derivative, because if the term with the x squared in it is going to go to the second derivative, it's going to be the same as the degree. So when I take the derivative of this, this is going to be -2 times 1 plus x. You subtract 1 from the exponent, you get -3. And for the second derivative, I bring -3 to the front, so I get 6. Times 1 plus x. I subtract 1 from the exponent to get -4. And here we are centered at x equals 0. So that means I'm going to find f of 0, f prime of 0, and f double prime of 0. Okay, so when you plug in 0 into the original function, you'll get 1. When you plug 0 into the derivative, you get -2. When you 0, I guess I mainly just have to do it for the second derivative, so you're going to get 6. So when you're writing this out as a Taylor polynomial, it's going to be something over 0 factorial. Then we have x to the 0 plus something over 1 factorial, x to the 1. Because it's normally would be x minus c, but my c is 0, so that's why I'm just writing x. So plus something over 2 factorial, x squared. So that's the term that I care about. So the number that's gonna go here, I'll just put the 1, then the -2, and the 6. So this would be my coefficient of x squared. So I did more work than I needed to. I really just had to focus on that one term. So 6 over 2 factorial is the same as 6 divided by 2, which equals 3. So that would be the coefficient of x squared. And this would be a second order polynomial here. If a different problem asked you to find the second order polynomial, just go to the second derivative.
Can you do 80 next, please?
Yep, let's look at 80. All right, so number 80, I'm gonna clear this out. So it tells you the rate at which the insects are destroying a crop, not a crop. So tons per day, where time is measured in days. So if it says how many tons, that's an accumulation. You've probably heard me say the word accumulation a lot this year. So how much of something? So if you want to get an accumulation, this is one of the main applications of integrals you should know. So you would undo a rate of change to get an accumulation. How much of something has occurred? So how many tons did the insects destroy? So I'm going to undo the rate of change. So this right here is my rate of change. So it's going to be 100 times e to the negative 0.3t. On the bottom, I get 2 minus e to the negative 3t dt. And we're going over this interval from 7 to 14.
I think
So
that's a 0.1 on the top. Pretty sure.
It's a 0.1. Thank you. You're right. So this is going to be a 0.1. So then you would just plug this into your calculator. And this is going to give you 124.992. But it says to the nearest ton. So normally you round to 3 decimal places unless it tells you otherwise. So here it tells you otherwise. So when you round this to the nearest ton, it's going to be 125 tons. So is that okay so far? It still feels weird. I would never get used to this.
Yeah, Morris, I'm just being 2 seats away from me. I don't know how I like this.
Yeah, this is strange. Well, it's better than nothing. Guess we have to work with what we got. This is what we got. Okay. So I'll take other questions. Anything on this page?
Wait, so when you when it asks for how many, you always take the integral?
When it asks for like how many or how much of something or the total amount, you would take the integral of the rate of change. You're undoing a derivative. So the classic example would be like, so this is probably worth a couple minutes to talk about. So just a simple example, like let's say you're going, I think this is when I first introduced this. It was, let's say from 2 to 5 hours, you're going 60 miles an hour. So this is your velocity. This is your time. So let's say you're going 60 miles an hour, a constant velocity of 60 miles an hour. Maybe it's going like this, but once you get to 2, it's constant all the way to 5. So from 2 to 5, if you're going from 2 to 5 hours, from hour 2 to hour 5, 60 miles an hour, how many miles did you travel? The total distance?
180.
Good, 180. So if you go 60 miles an hour for 3 hours, don't you go 180 miles?
Yeah.
Everyone's okay with that? 60 miles an hour for 3 hours, you've gone 180 miles. What's the area of this rectangle?
180.
180. This is a 3 by 60 rectangle. So it has a base of 3. It has a height of 60. So didn't we just undo a velocity? Isn't velocity a rate of change? So if you take the undo the velocity, that tells you how many miles you went. So if you went 60 miles an hour for 3 hours, when you undo the rate of change, you have a change in position of 180 miles.
Thank you.
Uh-huh. Okay, other questions on this page?
Is it 83 on that page?
Let me check. Let's see. It's not. But any other questions on this page, then I'll do 83 when we go to the next page.
Can you do 78?
78, yeah, let's look at 78. Okay, so on 78, it says the radius of a circle is increasing at a constant rate. So here we're trying to translate this into calculus language. Increasing at a constant rate of 2 meters per second. So what that means is dr, so this is number 78 here. So dr over dt is, if it's increasing, it's going to be positive. If it's a decreasing, make sure you use a negative sign. Here it says it's increasing at a rate of 0.2 meters per second. And it's asking, what is the rate of increase in the area of a circle? So that's going to be dA over dt. So that's going to be a question mark. That's what we're solving for. At the instant when the circumference is 20 pi. Okay, so right here, the circumference is 20 pi. And there's different ways you could do this. Don't feel like you have to do it exactly how I'm doing it, but I would say the circumference is 2 pi r for a circle. So when you divide both sides by 2 pi, you want to find out at the moment the radius is 10, what the rate of change is of the area. Okay, so the area of a circle is pi r squared. So I'm going to take derivative of both sides because I'm trying to find dA over dt. So I'm taking it both sides with respect to time. So I'm going to say dA over dt. And isn't this cool? If you take the derivative of the area of a circle, you get the circumference of a circle. Hopefully that just blew your mind. So 2 pi r, but because we're taking the derivative of the radius with respect to time, I have to do chain rule here. So then I take the derivative of r with respect to time, which is dr over dt. And I know what dr over dt is. It's right here. So I can take this and substitute it for dr over dt. And I can take this and substitute it in for r. And then I have everything I need to solve for dA over dt. So the area at the moment, the radius is 10. I can find how the area is changing in terms of meters per, or square meters per second. Okay, so this is going to equal 2 pi. All the answer choices, leave it in terms of pi. So times 10 times 0.2. Well, 0.2 is 2/10. So you do 10 times 2/10 is just 2. So 2 pi times 2 is 4 pi. So that's going to be letter C. So dA over dt. When you simplify this, you get 4 pi square meters. The area is changing 4 pi square meters each second.
Mr. Morrison?
Yep.
Since 2 pi r equals 20 pi, could you just substitute all of that for 20 pi instead of doing like...
That would have been smart. Remember, as I was doing that, I said there's different ways you could do it. That would have been a better way.
Okay, thank you.
Mm-hmm. So 2 pi r, you could have just changed it right away to 20 pi. You don't even have to solve.
Wow, Tyler did something smart. That's crazy.
He does lots of things smart. Now, you're just noticing now.
I'm a genius, Nate.
Mm-hmm.
I don't want to put you on blast, but what's your grade in this class?
Nate is just peanut butter and jealous.
Hey, chill. Hey, chill.
Let's not out people like that, bro.
Man, I miss being in calculus class.
Having to be nice. He
Your
doesn't.
mom miss being in calculus class.
Okay, so anything else on this page? Okay, did someone say 84?
83.
83, thank you. I can't remember it. All right, so 83.
81 too.
Okay, just remind me. I'll probably forget. So let's do 83. All right, so on 83, it says the rate of change of the altitude. Oh, that's the wrong problem. Let me actually zoom in a little more. So for 83, it says is continuous and differentiable on the closed interval. Which of the following statements must be true? Okay. So right here, letter A, it says the minimum value is 2. Well, it tells us what happens at 0, 1, 2, 3, and 4 for those x coordinates, but do we know what happens in between 0 and 1, or in between 1 and 2, or in between 2 and 3? It could go lower than 2. We don't know. So I can't say for sure. It says which of the following must be true. I can't say that this one must be true. So I'm going to cross that out. For the same reasoning, I don't know the maximum is 4 because we don't know what's happening in between 0 and 1, or between when x is 1 and 2. So I don't know that this is true. Letter C says f of x is positive for x between 0 and 4. It looks like it might be, but again, we don't know what happens between 0 and 1. It could go way down to a negative x value. So I can't say the y coordinate's always positive. Letter D, it says the derivative is always negative. Well, that's not true because it's increasing to get to 4, but then it starts decreasing. So it's not always going to be 0. So the answer has to be E. Let's just talk about why. There exists C, with C in between 0 and 4, where the derivative is 0. Okay, if we know it's continuous and differentiable, it can't be a pointy place or anything like that. So it has to go, it goes from, I'll do like a quick graph here. We're in quadrant 1. So we have 0, 1, 2, 3, 4. Just a quick sketch. So 0, 2 is here, 1, 3 is here, 2, 4 is here, 3, 3, 4, 2. It can't be a pointy place. So at some point, it has to have a gradual change in slope. So somewhere like to start going down, there has to be some point, I don't know if it's right here, but somewhere it would have to have a tangent line that has a slope of 0. So E would have to be true. There's no way that it could not have a slope of 0 branchable at every point in the interval, which it says in the directions that it is. So is that okay for 83?
Yeah.
So sometimes it's good to just draw a graph at the beginning for problems like these to kind of get an idea, but we're only given 5 points. We don't know what happens in between those points. It could do weird stuff. It could go down like this before it comes up. We don't know.
Okay.
Okay, other questions here?
81.
81, that's right, thank you. So 81. Problems like 83, I don't know why, but I could see something, one of the problems being somewhat similar to that one that just tests your ability to kind of like explain your answer, something like that. But that's just, I don't know for sure. This is a guess. Okay, so 81. So the graph of the function is shown above. So the value of the limit is x approaches 1. Okay, so on 81, I want to find sine of f of 1. Well, f of 1, at f of 1, isn't that defined right here? Actually, the limit, though, you know what? It's not going to be that point. That's just a distractor. So the limit of this, let me change this to be x. So as x approaches 1 from both sides, so from the left side and from the right side, not at 1, but as it approaches 1 from both sides, isn't it approaching the y value of 2? So I could think of this as this value is going to equal sine of 2. So as x gets closer and closer to 1, according to the graph, this limit is going to equal sine of 2. So just figure out what sine of 2 is on your calculator, and that's your answer.
That's it? I swear,
So
bro.
this point right here is a distractor because that has nothing to do with the limit. The limit is what is the y coordinate as you get closer and closer to x equals 1 from both sides. And that would be 2. So then you just plug that into sine. So sine of 2, do that on your calculator. That'll give you, in radian mode, that'll be 0.909. Okay, other questions?
82.
Which one? 82?
Yeah.
Okay, so let's look at 82. Okay, so on 82, we're given the rate of change of the altitude of a hot air balloon given by the function. Which of the following expression gives the change in altitude of the balloon during the time the altitude is decreasing? Okay, so this one, if you were to graph this right here, this is describing a rate. So when you're graphing this on your calculator, letting r of t be y and letting t be x, when you graph this on your calculator, the graph is going to look like this. It's going to start going down. So it starts off where the rate of change is negative, and it's going to start going back up. So where the rate of change is negative is going to be from this point to this point. So you just find the zeros on your calculator. And then this first zero is going to be 1.572. When you find the second zero, it's going to be 3.514. So when the rate of change is negative is when this graph is below the x-axis. So from 1.522 to 3.514, so that's going to be letter D. Because again, the graph is describing a rate of change. So negative is when it's below the x-axis. So if you want to undo that rate of change when it's negative, you just take the integral from this point to this point. So from here to here. Mm-hmm. Okay, other questions on this page? Sorry, what's that again?
Morrison, is the 82 actually D?
Probably not.
D has
It was A.
derivative of R2.
It has the.
Yeah, it's not the derivative. It's
Yeah,
it's
thank
RT.
you. I didn't look at it closely enough. Okay, so here I didn't even see choice A. I just looked up and saw D first. Okay, so yeah, you're not undoing. It's already given to you as a rate of change. So you're just undoing the original rate of change, which is R of T. So right here, if you're just undoing R of T, it would be A. Wow, they're evil to include D as one of the answer choices. So yeah, A is correct. Sorry about that. Then limits of integration were right. I just didn't look at it close enough. Okay, I think I heard someone asking a question earlier. I couldn't hear what you said though. Could you say that again?
Zong.
No. Zong, were you saying something?
I did a short command on my computer to unmute my computer, and I held the button, so it just kept on going mute, unmute, mute, unmute.
Oh, okay. Because yeah, it was like broken up. That makes sense. Do you have a question? No. Okay.
Can you do 87?
87. Yeah. Let's look at 87. Okay, so on 87, so it gives you a velocity function and it says it's asking about the position. So we're going to have to do integral. So right here, okay, so 87, it's going to be, when I take the integral of both sides, I can say the position. Okay, so 87, I'm just going to say, because it says along the x-axis, I'm going to say my position is x of t. Okay, so this is going to equal the integral from something to something of cosine of 2 minus t squared dt. Okay, so if you were to graph this function on your calculator, it's going to look like this. So when is the position first equal to 0? So that would be, or when the velocity is first 0. So right here, you would graph this on your calculator. You figure out the x-intercept, which is 0.655. And we did at t equals 0. So you're undoing the rate of change from where we started to where the velocity is 0. So from 0 to 0.655. And you would plug this into your calculator, and this will give you the new position on the x-axis. So it says we're starting at t equals 0. We're starting at 3. Where's the 3 come in? Oh, then actually, yeah, then you'd have to add the starting value. So then at the very end, add 3 to that, because you started at 3, so you're doing the net change from 0 to 0.655, and you're adding 3 because you started at 3. And then that will give you an answer of 2.816.
Mr. Marston, how'd you get the 0.655 part?
You have to use your graph this on your calculator and then figure out the x-intercept. That's when the velocity is 0. Because it says when is its velocity first equal to 0? So you have to undo the rate of change from 0 to this point here where the velocity is 0.
Okay.
Okay, other questions here?
Can you do 89?
89, I can. Let's do 89. You guys are so much nicer to me online. Compared to my 4th period, this is like, I feel the love in here.
I don't know what you're talking about.
Okay.
Fifth period is still amazing, though, just saying.
Okay. All right, so 89.
Second period sucks.
Nate,
okay.
1/4. I miss you, dude. I want someone I can talk to.
Bro, that'd be so much fun. It's so boring in second period. Nobody talks.
Person would hate us, dude. Us sitting. Oh my god.
Okay, most of them like second period though.
Nate, we gave you all you wanted in second period.
It's the best.
We gave you everything you wanted, Nate.
This is true. This is true. But now that was all for nothing because we can't even sit in those seats anymore.
It doesn't matter because you can do whatever you want now.
I can put your screens next to each other. Okay, so on 89, I am going to find the region of the graph. So we're going to go from, let's see here. Graph. All right, so if it's using this in the x-axis, I want to know where they intersect. So on the x-axis, that's where y is 0. So I'm going to say 0 equals 2x minus x squared. So I'd solve this equation. I'm going to bring x squared over here, minus 2x equals 0. And then factor out the x. So it's going to occur at 0 and 2. So I don't know what the graph looks like, but what is it? It's a quadratic. So that means it'll look something like this. It'll go through 0 and through 2. So I'm going to integrate from 0 to 2. And I have cross sections perpendicular to the x-axis that are equilateral triangles. Okay, I don't know how I'm going to draw that here, but perpendicular to the x-axis. You have to imagine this is coming off the screen. These are equilateral triangles. So the formula for an equilateral triangle is s squared radical 3 over 4. Each side length is just going to be the y coordinate. So if you want to find the y coordinate, so this side goes to the y-axis. So instead of s, I'm going to use this and have it take the place of s. So it's going to be 2x minus x squared. And then I'm going to square that, times it by radical 3 over 4 with respect to x, and then just plug this into your calculator, and that'll give you the volume. So you plug this into your calculator, it's going to be letter D.
Mr. Morrison, how do you know the y
Yeah.
coordinate represents the side length of a triangle and not like the actual height of an equilateral triangle?
I probably should have drawn it a little better. Let me see. It's just, if it's perpendicular to the x-axis, one of the sides, one of the sides is going to be the y coordinate, and then the triangle is going to come off the screen from there. So this would be one side, and then this just comes off the screen. So this makes it perpendicular to the x-axis. That would be one side length, and then the other two sides are coming off the screen like this. So the side length of the triangle is just the y coordinate of the graph.
I mean, but doesn't that just mean when they say the cross section is perpendicular to the x-axis, doesn't that just mean they're talking about like a vertical height?
It's not referring to the height. It's just the solid. Each
like,
cross section is perpendicular to the x.
Instead of it being perpendicular to like the y-axis.
Well, it was the y-axis, then it would go a different direction. If it was the y-axis, then it would look like this. So you'd have a side here, and then you'd have a triangle that came off the page. You have a side here, and then a triangle that came off the page. That would be perpendicular to the y-axis.
Mr. Morrison.
Seems a little slow to respond right now for some reason.
Mr. Morrison.
Okay, so is that okay for 89?
Why do you go from 0
yeah.
to 2?
Because I solved this equation, I wanted to find these intersection points. So I set the equation equal to 0. I just changed y to 0.
Okay.
So is that okay for 89? Okay, so I'll probably try to finish this up on Wednesday. I think we could should be able to stay on schedule this week. We're meeting Monday, Wednesday, Friday. So I'm not going to start any new problems, but if you have quick questions, you can stick around. Otherwise, I'm glad you were all able to make it on here. Hope you're doing well. You can always email me too if you have a question. So thank you, everyone. I'll plan on seeing you Wednesday, 10 a.m. Don't forget about the extra credit in the blue book. And then 1998 AP exam is due Wednesday morning. So stick around if you have questions. If have a good couple days, and I will see you all on Wednesday. So take care, everyone.
Thank you.
Thank you.
Have a good day, Mr. Morrison.
Thank you.
You too, Eddie.
Thank you.
Bye.
Bye.
Thank you.
Thank you.